Thank you, everybody, for joining this session. So I want to thank indeed the Azure staff for having me today. So, well, as you can see, the talk is going to be about 75 minutes. The good news is that it's going to be recorded. So if you have to basically leave before, you can always watch it back. So that's the good news. Also, it's going to be very broad today, so I think it's going to be intensive. Might be quick at some point, so I can't see you, so I can't see your reactions, so maybe I will lose you at some point. But again, you can always watch back if it's a bit, let's say, too intensive. So I'm Stephane Eyskens. I'm a code solution architect, so you can follow me on Twitter. And we can exchange, about any Azure-related topic. I'm quite responsive, let's say, whenever the occasion is there. So orchestration, what is orchestration? So I just took the definition of orchestration from Wikipedia, and I kind of share this definition. So it's the automated configuration, coordination, and management of computer systems and software. So it's a pretty broad definition, so because it means that you have some orchestration bits at the level of the application, some orchestration bits at the level of the infrastructure. So we're going to see a bit both of that today, right? So also something that came in the picture, because basically when I submitted this session was quite a while ago, and in between we can say that Kubernetes, so AKS in Azure, took a lot of space, right? So it's becoming really a prominent service. And so I could not ignore this. So it's going to be a mix of Kubernetes-related, let's say, topics, of course, still in the context of orchestrating, let's say, components, but also Azure native services, right? It's going to be a mix of both. So also just one word, and then we'll get started into the meat of it. You see some maps behind, right, in the background here. So I think Martin has also pasted, let's say, a link in the chat, right, where you can basically also have, some vision on Azure architecture in general, so nothing to see with this. I'm gonna use some maps that are not published yet on, let's say, scope to the topic of today, but you can always have a look at that. It's a good way of grasping, let's say, the broad landscape of Azure, right? Okay, let's get started. So for the agenda, we're gonna first come back to the basics, right? It's really a few slides, a lot of demos today, so don't worry. But first I want to basically step back and really find what's a message, what's an event. Sometimes you have some confusion in that. Then we're going to see a small map about event-driven architecture. So what are the usual suspects you have today, let's say, when you want to build an event-driven architecture, but also messaging. So we're going to see a small demo of KIDA. So I'll elaborate on this later on. We're going to see also a small demo of Dapper. So Dapper, of course, and KIDA as well, it would deserve a full talk. So it's broad enough to have a full talk. So here we're going to see a glimpse of it, and mostly about orchestration, right? Then we're going to see logic apps versus durable functions, so when to use what. And I will basically demo logic app through Dapper. Okay, so that's kind of something also quite handy that Dapper makes available to us. And then we're going to see the durable functions. So that's probably the most complicated one. So that's going to be also orchestrating some events, let's say, some steps, some workflows using the durable function framework, right? Inspired from a real world project. So let's start with message versus event. I just realized I didn't start my, let's say, counter, so I will, sorry, but do it in the meanwhile, because I could lose track of the time. And especially here, I don't see anyone. So I'll just make it to make sure that I will not go over time, because it's already a bit longer than usual. Okay, fine. So in messaging scenarios, usually you can say that a message, right, a publisher that will push a message onto a bus is actually agnostic from its subscribers, but basically the intention is that you have at least one subscriber. And usually the message itself will define a business object or an entity, and basically the subscriber will conform to that, let's say, entity. While in pure eventing, you might have, let's say, a blob that arrives on blob storage. So Azure Blob Storage is able to publish that event that, for instance, a blob was created, but it doesn't know if anyone will pick that event up, right? So the intention is a bit different. So similarly, if you compare, let's say, the payload of a message versus the payload of an event, of a message describing an event, in messaging scenarios, the message often contains the actual data, right? So if I take, for instance, CRM, and you are interested in changes happening in CRM, Then CRM will publish over the bus maybe an entity, and the record itself will be part of the message, right? And while in eventing, again, if I take the example of the blob storage, the message itself will contain maybe the name of the blob, the location of the blob, and that's about it, right? So if you want to notify a system about the fact that an order has been submitted, again, the message will contain the order identifier, maybe, will contain the timestamp, and that's about it, right? Not the full order. So that's a bit different. So that's all about semantics, because technically speaking, it's not actually a real difference, right? But, that's the semantics. So in messaging scenarios, also, you kind of have sometimes transactions. You might have also some messages that must be processed in certain order by the same subscriber. In eventing, it's less the case. Usually eventing are really decoupled, and then somebody or some process picks up the event, does something in a decoupled way, let's say, and each event is decoupled from the others, at least in discrete events. But that's also something that you see often in messaging scenarios versus eventing. Now, a real technical difference, and especially it's applicable to Azure, is that, for instance, in messaging, messaging systems are often based on the pool model. So if you take Azure Service Bus, if you take both the .NET SDK or AMQP, it will be based on the pool model by default, meaning that from an architecture standpoint, your focus should be more on the service bus capabilities. So how big could a queue be? How big could a topic size be? And then, of course, you know that you will read those messages at your own pace. So for the rest of the architecture, you're kind of confident that you will not be overwhelmed, right? Because then the focus is more on service bus itself. So it's possible to have some sort of push model with service bus. With AMQP, it has something called link credits. It's simulating a little bit a push model, but still the receiver is in the driving seat in terms of how the message should be basically sent by the bus. While in for instance, pure event-based systems like EventGrid, it's going to be a push model, right? So here it's a game changer in terms of architecture, because basically the pace will be imposed by the service itself. So if EventGrid can absorb, let's say, 1 million messages a second, 1 million events a second, will you be able to follow that, right? Will your handlers be able to follow that pace? Say that you might say, yeah, I'm going to use Azure Functions, host it on, let's say, the consumption tier, and it will scale accordingly. Maybe, but maybe that function is actually calling an API that is not scaling the same way, right? So you might have somewhere in the chain something that's not scaling or not able to follow the pace imposed by EventGrid. So that's a real technical difference that I see. But I would say that boundaries between messages and events are very tiny, so hence the confusion. And also that you have more than often service bus used in an event-driven architecture as well, right? So that's a bit for the semantics. So in terms of the event-driven architecture, the usual suspects we have. So I built a small map, let's say, to depict a little bit the landscape of the components that we can use in the context of Azure and Kubernetes a little bit. Of course, it's not comprehensive. It's also scoped on the AKS. And well, we won't go through all the map, but maybe something interesting to know for eventing if you are dealing with discrete events. So again, discrete event is like an order was created. So it's a single event, isolated event. Then you will use EventGrid. Usually, if it's telemetry series, you would use EventHub. If you want to push or broadcast some notifications to like mobile device, you would use, for instance, notification hubs. For event sourcing scenarios, you might use Cosmos DB change feeds, so there would be alternatives, but that's a way of achieving this. Also here you see that on the Azure Services, that's also Azure Services, of course, here. In messaging, of course, Azure Service Bus, that's a no-brainer. That's the one, let's say, to use somehow. And for simple scenarios, you could use storage queues, right? If you don't have, let's say, a too complex story, storage queues might do the job. In terms of workflow, so that's actually what I'm going to demo today. We have durable functions and logic apps. So durable functions, well, I'll elaborate on that later on. And you see that I made a dotted line between logic apps and Dapper, because Dapper now has a logic apps wrapper, right, that will leverage the logic apps runtime for a self-hosted logic app workflow, basically. Yeah? So in this case, I would demo that into AKS. So in terms of logic apps as well, it's mostly used for system integration, right? So because there's plenty of connectors. So on the handling side of things, you have, let's say, some building blocks that you can use. So I like container instances. Why? Because these guys will bring you the compute. And it's serverless. So usually when you have messaging or eventing architectures, it's not always easy to predict the amount of events you might have or messages. So it's also good to be able to scale according to, let's say, the loads without prepaying everything. So that's one benefit of using container instances, is that they will bring you the compute when needed. It's going to be ephemeral, and then you discard them when you have handled your event or your message. Of course, Azure Functions, that's a no-brainer. In Azure, that's also, it has all the bindings, let's say, to all these storage stores or and event stores. It, of course, can leverage the webhook functionality that you could basically also use to, for instance, trigger an Azure Automation runbook when it comes to more infrastructure bits. So that's kind of building blocks you can use. In Kubernetes itself, there is more than this, but let's say one solution that is really nice is KIDA. So I'll elaborate on this as well. But the goal is to scale out basically the infrastructure that is used by your handlers. Right? So, and of course, that's also a sort of orchestration, right? So it's not only on the application side of things, it's also needed for the infrastructure. So that's basically a bit the landscape. So let me look at the clock. Okay, so before demoing KIDA, so I told you there will be not so many slides, but before demoing KIDA, I will just take one diagram that you can find on the KIDA GitHub, which I should have added basically the link. But anyway, if you Google KIDA, you will find it right away. So what is the value proposal of KIDA is to bring the intelligence of Azure Functions into Kubernetes, right? So, and when I say Kubernetes, it's of course, could be AKS, could be a self-hosted cluster, could be in Amazon, basically anywhere. And so why do I mean that it's the intelligence of Azure Functions? It's because Azure Functions, the hosted functions, right, by Microsoft, they have bindings, as you know, and they will basically monitor the sources. So like storage accounts, like whatever store you are binding your functions to, and they will basically look at the state of these guys, right? And so they can scale according to the number of messages arriving, or let's say, or events arriving somewhere. Yeah? So, and KIDA does the same. So KIDA is a metric server that you can inject into your cluster, and so KIDA will monitor these external sources. Again, not only Microsoft, so it could be Amazon stores, could be RabbitMQ, could be, they have a lot of connectors, we'll see that. And so it will monitor this, and then it's leveraging what is called the horizontal pod autoscaler, HPA, which is a built-in component of Kubernetes that will basically scale out your pods, which are your handlers, right? And you embed, let's say, the function runtime as part of your handlers. It's not a hard constraint. You could say that you could basically put something else, right? But the goal is, of course, to use that in conjunction with KIDA, right? The default, let's say, handling is leveraging the Azure function runtime. And then, of course, these guys will handle the message as they need, right? Or events. And then, and that's about it. And so you have to register, of course, your KIDA definitions, so to Kubernetes, so that it knows what has to be monitored and what has to be scaled out, right? That's the big picture. So let's see. Yeah, that will be for just after. Let's see this KIDA in action. So I have basically, let me first check my pods, right? So, so yeah, I have no pods running, so that's okay. I will basically show first KIDA in action, then I explain a little bit how it works. So I have a queue writer here, so I will basically scale a deployment and would start, let's say, writing messages to a queue, right? So I will basically scale this guy. Okay, so it's actually a bigger size than what I use usually, so I'm a bit perturbated by the size, but that should be okay. So, and then it's scaling right now. So if I go to this, to my storage accounts, I will actually see this, right? So if I take the where are you? So the Storage Explorer. I have a storage account with a simple queue, well, even more than one queue, but anyway. So let's take this one. And basically, you see here that there are some messages in the queue, right? So if I also, given the size, it's harder to refresh. But anyway, so if you see here, I have messages that are being added to the queue. You see 47, and no, let's see, 57. So Kida should at some point start some pods, right? My handlers. So let's have a look at my pods. I will actually do it. So, okay, so now you see this guy here is actually one of the handlers that has been started, right? Because Kida is monitoring the length of the queue that you saw, and it's basically, it has started a handler. So normally now I should start seeing less messages, you see, so they are basically dequeued. So that's how it works. So in Kida scales accordingly, of course. So if I say that I'm gonna, let's say, go from 1 to 35, let's say, pod, right? So I will really scale out my writers. Then of course I'm going to have more messages, and then Kida should detect at some point that it's one listener is not able to follow the pace anymore. So you see here we see more and more messages, but of course my writers are still running. So if I just do this, I have a few that are running already and a lot that are still in container creating mode. And if I basically select, let's say, only the rears just to see, it's still one, but at some point it should start others, right? So let's maybe wait a little bit, and then let's see if it does it, right? So of course it's doing that based on metrics, but I'll show you that that you configured. So if you say that the target is like to have 2 pods and then two messages, and then it should start scaling out as soon as there is 2 messages in the queue, then of course you will see, right, keep monitoring the queue. Yeah? So that's a bit this. So let's have a look to see if no, it started others. Yeah, that's a demo effect. It will not start any other one. Normally it should, or maybe my writers are still actually not completely starting. So let me check. I know they are there. So it seems that maybe I don't have enough. So anyway, I could, yeah, because you see, so the queue is kind of quite well emptied even by a single one. So that's why. So I could basically scale up my writers to even more, but I will not lose too much time in that. You understood the principle, right? So what I actually will do is stop my writers just to make sure I do not, forget these guys and have a huge bill by the end of the month. So I'll just scale it down. But basically here, it's monitoring the queue, and if the length becomes too big and one handlers cannot follow the pace, it will scale up others. That's how it works. So here I'm scaling down this guy. So what is also interesting to show you, I told you that it's leveraging an HPA, right? So so let's have a look at the HPA that I haven't deployed myself. It has been deployed by Kida, right? So then I'll show you how to do that with Kida. So if I take the queue, right? Or this one, sorry, and I describe it. So then you see that, well, Kida has added some labels on it, right? It's managed by Kida operator. You can see that the queue length right now is 0. The target is 5, so meaning that above 5, it should start to kick off stuff. That the maximum number of replicas. So that's something I would really encourage you to do. So whenever you deal with Kida, just make sure you specify a limit, right? Because Kida say that your queue is not able to, or you're not able to follow the pace, they will scale out, right? Until you might have troubles at some point, maybe in your cluster itself, that it doesn't have enough space. Then you will have containers maybe in a faulting state. So that's something I would encourage you to do, also to limit the potential harmfulness that a single application could have in your cluster, of course. There are also other ways, of course, to control, let's say, resources used by an application, but that's one advice, to always put a maximum here. And so basically here, then you see what happens for that HPA, and then it should at some point, let's say, stop. It's already gone. And the queues are still 2. Yeah, so these guys, so my writers are done because I scaled down the deployment to 0. Queues are still there. So that's interesting, because here it means that by default you have like a conservative approach. So you see the queue is of course empty, because now let's say I even don't have any writer. My pods are still there because you have a conservative approach. So you have something called the cooldown periods. That's by default 5 minutes, that you can basically adjust if you want, which most of the time is not required. But what is interesting to see is that, if you really have long-running operations, say that you have a message, and that to handle that message, you actually have to go through a bunch of steps that could take a long time, then the risk of using deployment together with KIDA and the HPA is that at some point that deployment could be killed, right? Or that running pod could be killed because the queue is empty, while it was still busy doing something. So there are some techniques to avoid this, right? So like only dequeuing when it's over, adjusting the cooldown period time, but also the best approach for long-running operations is to couple KIDA with jobs. Okay, so they also have a scaler for Kubernetes jobs, which then of course will only be stopped when the job is over. Okay, so that's kind of a tip. So something that I learned very recently, because KIDA has plenty of connectors as well, is that you can even scale your HTTP workload, so it's your APIs, based on by combining Prometheus with KIDA, right? So you can send metrics to Prometheus, KIDA can scrape that, and then basically scale your HTTP requests accordingly. So or HTTP APIs accordingly. I've not tested this one, but that sounds like a nice approach. So here we've seen the handlers running inside the cluster. So I told you that I also like to associate serverless capabilities with event-driven architectures just for scalability reasons. So if I take still KIDA, but this time I have like a blob scenario where I have large blobs to parse, right? Say that I have blobs arriving in a blob storage, and basically my handlers have to open that blob, do some stuff on it, and it's consuming some memory, right? That could be an issue because, of course, if you run that from within the cluster, let's say, of course, Kubernetes AKS has some scaling capabilities, auto-scaling capabilities, but when it comes to memory, it's a bit more challenging, right? So then a good approach could be to combine KIDA with virtual kubelet. So I'm gonna basically now go to, let's say, my blob service, and let's imagine that I'm basically uploading large files, right? So here it's going to be very tiny files because I don't want to lose time, but you get the idea. So I'm taking these 10 files. So here again, KIDA will basically detect that files are coming, right? So if I get the pod again, at some point it should start to, you see now my queue listeners are, let's say, gone. So it should basically start the blob handler somehow. So actually it's slower than usual, so that must be the demo effect. But anyway, so let's see, okay, it's there. Okay, so this is one of the receivers, so it might be start one, maybe more. And this guy is actually registered in the deployment. I'll show you that in a bit. I'm telling Kubernetes that I want to use virtual nodes for this. So in AKS, it translates to ACI, so Azure Container Instances. And again, remember the scenario, I have large blobs, right? So handling that within the cluster could put the cluster at risk, especially memory, because memory is not compressible, right? So if you use CPU resource, memory resource in Kubernetes CPU, Kubernetes has some techniques to basically compress, somehow throttle your CPU request, but that's not doable with memory, right? So it could be an issue. And since it's mostly the scaling story in the cloud, especially Kubernetes is more scale out than the scale up, then memory at some point could be an issue. So running virtual kubelets for this could be interesting. So if I go to Azure and I start to, let's say, look for my container instances, then I should have, you see, it started 2. And so what is interesting is that in that scenario, although my files are, of course, very tiny, but you know they should be big, I allocated per handler, let's say, some quite a lot of compute, right? So if I go the screen resolution, sometimes it's a bit harder than to see. Wait, I wanted to show you a bit the, you see, so I allocated 2 CPU cores and 10.4 gigs per handler, meaning that then I have much more space, and that's virtual, so it's not inside the cluster itself. If I would try to do the same inside the cluster, then I need to have serious node sizes, right? To make sure that I could do that, or a single process might eat everything, right? If I don't have proper policies in place. So then virtual kubelets for this could be interesting. So it's the same principle, of course. If I have a look now, probably my blobs are, it's not gone yet. It's actually even surprising. So it should be gone at some point, right? Because that's what my handlers do. Container instances have like let's say, a small overhead when at start, right? So that's why I think it's still pending anyway. So it should be gone at some point, and my blocks will be handled, right? So that's the downside of container instances, in that it takes a bit of time. So you could see that the queue listeners were started very quickly because it's inside the cluster. If it's outside the cluster, it's more in an asynchronous scenario. For large stuff that are compute intensive, that you should then maybe rely on virtual nodes, so that you have a good balance, right? So it all depends, of course, on the scenario, but that's a way of doing that, right? So it's taking a bit of time. So Azure seems to be tired today, but anyway, so I'll leave it that way to begin at some point, right? So so that's an interesting one. So let's focus in the meantime to to Visual Studio Code and see a bit how that works in practice, right? So I'll just show the blob one, okay, because the queue is very, very close to that. So my blob reader is basically just a function, right? So like if you would write a function hosted by Microsoft, so it's no difference. So there's a blob trigger, and I'm simply deleting the blob, right? So I'm not doing anything, else but deleting the blob. So if I look at the Docker file, because of course you need to push that to Kubernetes. So I'm using an outdated version of .NET Core, but anyway, that doesn't matter for this demo. And then I'm also using the Azure Function Runtime. That's packaged as a container and then or an image, and then basically, we deploy that later on onto Kubernetes. So if I look now at the deployment bits, because that's basically where the magic happens. So I have basically my some Azure storage related info, and then. And by the way, you can handle that differently as well, but okay, it doesn't matter. And here I have my deployment, right? So the only difference, that's still nothing to see with Kida here. The only thing to remember is the name of the deployment, which is basically somewhere. Azure blob. And then the spec, okay, I'm just specifying the image, where I get the secret from. And then here, this is the virtual node bits. So that's how you instruct Kubernetes, or AKS in this case, to basically use ACIs, right? So Kida is agnostic to that. Kida doesn't know about this one. Okay, what Kida knows is actually what you describe here, right? They ship with custom resource definition, known as a scaled object, and basically here you define what's the target deployment. So if you use deployments, remember it can also use jobs, and so here of course must match the name of your deployment. I specify the max replica count as being 10. And then the triggers is all their supported triggers. So in this case, it's an Azure blob. And then, of course, I'm just specifying which container the blobs are in, and that's about it, right? So that's what Kida will basically do to deploy the HPA that I showed you just earlier. Okay, so that's how it works, Kida, in a nutshell. And let's maybe have a quick look just at the state to see if the blocks, it seems that ACIs, I don't know, there is something not going very well. It's really incredible, because I think I probably did that at least 100 times, and usually there is absolutely no problem. Anyway, let it go, and we'll see. So here you might say, okay, great Kida, but why would I use Kida when I know that I could just use the hosted functions runtime from Microsoft? Because basically it's of course easier. With the hosted, let's say, the consumption plan of Microsoft, you just push your function code and that's it, right? So you have nothing else really to worry about. So what I see as a good use case, it's actually depicted a bit on this map. So I'll first start with the easy bits, and then we'll come to the more complicated bits. But so if you, of course, need to tackle or deal with non-Microsoft sources, then Kida is, of course, a good approach. If you basically want to self-host the functions anywhere, so else but in Azure, then of course you can run that in another cloud, you can run that on-prem. If you want to mimic a little bit the serverless capability of Azure Functions, then you can use the virtual kubelets, as I told you. Of course, you have this, it's more than a cold start. In Azure Functions consumption tier, you have a cold start. I would say the ACIs, that's a double cold start, right? So it's actually quite, and it's every start, right? So it's not like you can warm them up and then it's fast. So you have this overhead. So only advisable in resource-intensive, let's say, use cases. And then you have, of course, on the function tier, well, it's easy, right? You have, again, nothing to do but just publish your code, cost-friendly, especially consumption tier. I would even call that a free service, to be honest. given what you pay, it's almost nothing. Capacity, well, you don't have to worry too much. Out of the box, it can scale out to 200 instances in parallel, so this is already quite a lot. So that's easy. Now, the pain point, let's say, is that more than often, companies don't like public-facing endpoints, so network can come into play, right? In two sides. For the function itself, that if you, let's say, host a function on the consumption tier, the function could be called, let's say, triggered by HTTP on the public endpoint. Of course, you need still to provide a key or maybe an access token, but still, from a network perspective, that's public. Some companies can't live with that. It's as simple as this. Then in that case, of course, if you self-host your functions in Kubernetes, that's already part of your private perimeter, right? So then you know that to reach out to that function, you probably have to go through an ingress controller and so on, and maybe a bunch of other devices that will control and make sure that the traffic is legitimate, let's say. Right? So that's a big step. And then on the other hand, it's also the function itself. If the function needs to reach out to one of your data stores, like your storage account or whatever, then if you want to restrict the data store access, then again, network could play a role, because if you use really function the consumption tier, yeah, then you can't restrict to a certain perimeter. You need to whitelist Azure services, which of course might be considered too broad. And now you should know that you can, of course, with Azure Functions, let's say with the premium, for instance, pricing tier, you can integrate with VNet, but then it becomes also costlier. So you have to make a cost, let's say, calculation on that, cost estimate. And also functions, the private endpoint for functions is in preview right now. Okay, so that you could not, let's say, hit it from there would be no public endpoint. But that's still in the preview right now. So I think that's the use case a little bit where you could choose for one of those. And also, if you at some point you say, okay, we do everything in AKS, then maybe that could be okay. Why not hosting functions as well? So that was for KIDA. Actually, I took a bit of time, so I'll try to go a bit faster. So demo of Dapper. So first, before jumping into demo, let's try to describe in a nutshell the value proposal of Dapper, right? So I took that from their GitHub. So the value proposal is to have an abstraction layer between your application code and the underlying stores, right? Whatever stores it might be. So Cosmos DB, Azure SQL, Redis. And basically, your application is agnostic to what store it talks to, right? It just has to follow some Dapper conventions. That's how it works. And it's actually damn easy to use. So that's really nice. So Dapper right now is in the alpha release, so it's still not advised to use that in production, but they aim at being production ready by December, right? Having a first release, so which is already good. So they cover all of this and even more. So service invocation is really for service discovery. You also have MTLS. That's a bit, the MTLS bits are a bit overlapping with some service meshes, but okay. State management, so reach out to state store in a seamless way. Again, not limited to Microsoft. Publish subscribe, so all the pub subs, so messaging, of course, and even think that's really part of the topic. Resource bindings and triggers. Actors, that is basically something that you also have in Service Fabric. So I've not used actors yet with Dapper, but anyway, I'm also discovering Dapper as we speak because it's really new. Again, not production ready. So observability today, they still need to improve a bit. I mean, the dashboard is rather limited right now, and a very handy feature is also the secret store. And I think that that's very nice, and also something you are not forced to use everything of Dapper. So you could also say, well, you just use subset of features. Of course, given the architecture, you have to make your math as well. These are all the, let's say, or maybe it already changed in between. So I made this map, let's say, like 2 weeks ago or something like that. But you see that they're already quite broad. For something that's in alpha release, they have connectors for plenty of things, right? Really plenty. So, and you can then imagine that from your code, you don't need to know anything about these things, right? So if you talk to Azure Service Bus, you do not need to embed the Service Bus SDK into your code. You just need to make calls to localhost, right? If you use HTTP or make gRPC calls, and that's all you need to know, and the Dapper convention. But we'll see that a bit in action. So that's the value proposal, really a real abstraction layer. So I will demo a Dapper workflow where we'll also see these goals, right? My workflow, because that's more in the theme of the topic of this session, so about orchestration. And here it gives me also the opportunity to explain you a little bit the architecture of Dapper. So here you can consider the Dapper workflow. It's actually a wrapper of the logic apps runtime. Okay, so they built a wrapper, and then the logic apps runtime is actually you can inject workflow definitions, right? And then you can start calling your workflows from Dapper enabled apps. And as I told you, gRPC, HTTP. And and of course, you have some input bindings that can trigger workflows too, right? And then the architecture of Dapper is like many Kubernetes. Well, it's not only limited to Kubernetes, by the way, but anyway, so for Kubernetes, like many Kubernetes services and products, it implements a sidecar pattern, so meaning that it will inject into the application pod, it will inject a sidecar container. That's the Dapper D container here. And all the traffic will basically go or fly through this guy. Okay, so that's a bit how it works. So when I said you're not forced to use Dapper for everything, that's true. Of course, the consumption of the Dapper sidecar you have also to measure, right? Say that you only use Dapper for secrets. Yeah, the cost benefit of using that for this only, you taking into account that the of course Dapper container will consume some resource for every application pod. You have to see the if that's worthwhile or not. And so here you could see that the Dapper workflow would be your application pod in the non-workflow scenario, right? So they ship on their GitHub with a very basic example of workflows. So I said, okay, I wanted to try something that would be more enterprise ready scenario. So what I did is that I took their workflow engine, so we'll see that in a minute. I'm using AED pod identity, so to make sure that the workflow engine, to which you can, let's say, attach one or more workflow definitions, is able to interact with non-Dapper, let's say, aware resources. Say that you need to interact with an Azure service that is actually not covered by Dapper, then you could still use managed identities to connect to design, right? So that in a secure way. So what I'm also doing here, of course, in the workflow, so this is more the steps of the workflow. I'm basically passing a text to be translated, right? So it's a workflow by translation. I'm getting, let's say, an API key from Azure Key Vault using the Dapper secret endpoint. So I'll show you this. I'm calling the Cognitive Service API. That's the translation service from Microsoft, which of course is my API key and the text that needs to be translated. And I'm saving the translation in the blob storage. Okay, so that's how it works. And then of course I return the response to the caller. So that's how the Dapper that's the scenario of this workflow. So let me show you that here. So first, I need to forward and maybe just see, because I'm a bit worried about the states. Okay, no, my blobs are gone, just to make sure, because I like to read. Okay, my blobs are gone. So, it was a bit slower than usual, but in the end it did. So let's have a look at then the Dapper. So I have, let's say, pod. That's this time it's well. When you install Dapper, let's say in the early days, it was automatically installed into your default namespace. So depending on the installation method, so that's why it's running here. But anyway, it's just not too important. So I'm gonna forward the port of this guy, right? So that's my workflow engine, right? That's the workflow engine from Dapper. That's the wrapper. And so now I will be able to interact with it because I'm forwarding the let's say the ports to my local machine, right? So, and to talk to my workflows, so I already have the payload here. So maybe I can just show you, because it doesn't cost me anything, the workflow they come with. So I can send a dummy message, doesn't matter, it will just be ignored. So yeah, sometimes you have also, like today it seems that everything is slow. That's crazy. Am I on the right port? Yes, it should be. Wait, let me come back here. Okay, it's been for a while. Yeah, sometimes as well. Yeah, that's kind of a locking. I don't know. I just hit enter here, and then no, it handled the stuff. But anyway, so they're basically demo. It's ready to get started, because what it does is simply returning a hello from Logic App workflow. So yeah, that's why I wanted to do something a bit more advanced, let's say. So if I now call my workflow, and by the way, I can already explain you a little bit the Dapper convention. So as I told you, you communicate let's say with the Dapper components through HTTP endpoints or gRPC. So it's a localhost Dapper version that will always be the same, let's say. And on this side, you will, depending on the action you do, of course, this side will change. So in this case, in the case of workflows, you say invoke, then you say that you are invoking a workflow, and then, well, I don't know why the method is there, but anyway, the name of the workflow is the name of your definition, basically. Okay, so that's how it works. And then, of course, here I'm just passing the text to be translated. So I'm kicking this guy. So it already made the translation, went through all the steps I mentioned. So if we have a look now at my blob storage, I should have, let's say, these files ready. So Dapper docs. So yeah, I already have. You see, it's not the first time I read it. So let me just delete this guy. And then if I just replay it a few times, that should create all the blobs. Right, so 5 times, and then it should basically create all the blobs, you see. So that's the output of the translation. And if I look inside, then I will have the same information as the one, of course, that I returned to the user, to the caller, right? So that's well, it's a French translation here, but it doesn't matter. So you see, and what is nice, because now I need to show you, of course, how it works, is basically that the workflow, because it's a Dapper aware workflow, is agnostic to, again, the underlying source it's talking to. So if I go to the Dapper workflow engine, and I go to my workflow code, come on. So this is the one. It's actually a logic app. So for people who know already logic apps, then that should be familiar, right? So you can even use the logic app designer. And then actually, once you have your workflow definition, just could use it in the context of Dapper. There are some limitations. It's not like full parity in terms of features, but still it's quite, especially for instance, for the connectors that Dapper is covering itself, then of course you would use Dapper connectors and not native logic app connectors. But if you see here, we have my 5 steps, remember? So I'm extracting an API key from Azure Key Vault, and you see for the Dapper, it's just a call to localhost. Secrets, that's convention when you talk to a secret store, and then I'm just giving the name of my secret store, well, which is not the actual name of the Azure Key Vault in this case. It's just the name that Dapper is aware of, and I will show you how Dapper can be aware of this. And then I'm basically calling, I'm just specifying the secret that I want to basically extract, right? That's the first step. Then the second step is calling the translation service. Then I'm basically just reusing this API key that I got from the first step. So in this workflow, you see that I'm using the retry policies of logic apps. And that's something that's still ongoing on Dapper, all right? They have revamped a little bit the way they want to retry. So now I'm brainstorming on how to do that. Should they delegate that to the Dapper users? Should they have like a default retry for all the components, but in a consistent way? So I think that's still ongoing. So right now I'm just using retries of logic apps. Here, of course, I'm calling my cognitive service. So that's, of course, let's say an endpoint that I have hard-coded here. It doesn't matter. And then here I'm saving the translation as you see the blob storage. And here again, I'm just, the workflow doesn't know that it's talking to a blob storage. It's just making HTTP requests to, again, localhost, and then bindings this time, and then the name of the let's say the store, right? And then I'm just returning stuff. So, and then how that magic happen is basically by deploying, of course, the proper components into Kubernetes. So if I look at this, so maybe look at the secret first. So Dapper comes with a resource type called components, and basically you will. Depending, of course, on what you want to talk to, you will choose the right type. So in this case, it's a secret store Azure Key Vault. And you will basically specify, let's say, the name of the vault. And as I told you as well, you can use, and that's good. So the secret component, let's say, or secret kind of component is integrated with AAD pod identity. So in this case, I'm using a managed identity that I've already created upfront that is also deployed. Let's say the identity bits are deployed into Kubernetes. I will not go to that right now. But this guy has access to my Azure Key Vault, right? So meaning that I don't need to disclose any sensitive information in say, my CI/CD pipelines or in, of course, in the YAML files. So if I go to my vault, here I have basically an access policy, right, on my secrets. And basically that's to this guy, right? I create this identity name like this. Well, actually, you could argue that I gave way too much permission because it just needs to get a secret. But yeah, anyway, I think I got lazy or whatever. Anyway, you see how it works. So you have, let's say, a component that's bound to an Azure AD pod identity that itself got granted access policy to key, right? Again, completely agnostic for the workflow itself. And that's the name of my, let's say, vault, right? And that's the name of my component. So that's the important bit, because if I take this guy, and I come back to my workflow, so you will see, of course, that that's the name I have to use, right, as part of the convention to target my secret store, right? So the only thing that the app needs to know, really, the application code, so here it's a declarative workflow, but say that you would write really an application, that's of course the same principle. You just need to know the Dapper conventions and the name of the components, which of course you could retrieve from configuration. So, and that's it. Right? So, and then if I look at my storage, so it's also a component. Let me close this. This time I name it translation, and then you see that it's basically binding to the blob storage, that the name is this one, and that I'm taking the connection string from, let's say, my keyval, right? Reusing a secret ref that is basically made available by the secret component. So basically you can reference components, the secret components from, let's say, from other components. So that's kind of handy too. So very nice Dapper. So I'll stop on Dapper now, but very nice. And I think you will need to keep an eye on that. It's really, really promising. So, okay, so that's it for Dapper. So maybe a quick intro on durable functions before the demo. And also we'll see when to use what, at least according to me. So basically, well, I will not go through all the patterns because we will run out of time, but the durable functions patterns are quite well described in the Microsoft doc here, right? So it's really suitable whenever you have to deal with such, let's say, such patterns, right? So I will just demo function chaining today, right? So in the context of workflow, but I will explain that in a minute. And the others, well, it's very well covered. Maybe something that, yeah, well, I think that's all I can say about it right now. Okay, so feel free to read more. So maybe let's see when to use what, according to me, right? So, well, what I see is that logic apps, it's fully declarative, as you know, so often used by infrastructure teams as well, because you do not need to have coding skills, right? It also comes with designer, so I didn't show you designer, but I suppose you already saw it, hopefully. Anyway, otherwise you can, it's really intuitive, easy to use, so simplicity. And it's really, really the one that you use in integration scenarios, right? So it has like plenty of connectors to almost everything, and you can also bring your own connectors. So basically, in terms of integration, sky is the limit somehow. So in terms of really system-to-system integration, well, I think Logic App is a no-brainer. And I would even use mostly the Logic apps, let's say, really hosted by Microsoft, so not especially the Dapper one. So that's of course different. Versioning, that's a big difference between the both. Versioning is really easy in Logic Apps. You don't have to worry about it, right? So say that you have a Logic App that has been deployed, you already have orchestrations going on, and then you deploy a new version. It's seamless for you. Azure will cope with it, right? Or Logic Apps will cope with it, will deal with existing running instances so that your changes will not interfere with the existing ones. In durable functions, it's actually the other way around, so you really have to pay attention to that. So I'll show you, if I have time, a breaking change, so that you see that indeed you better know what you do, right? It's imperative, so it's coding, right? So it requires coding skills. But then, of course, because you can leverage, for instance, .NET Core framework, yeah, then you have full flexibility as well in what you need to do, right? So it also has some sort of actor model through durable entities. So basically, it's, let's say, in a nutshell, stateful services or stateful isolated services that you can use actually in your orchestration, right? If you need at some point to store, let's say, a business state or whatever, you could use durable entities for this. Of course, then it's mostly used by development teams because it requires coding skills, and but of course the versioning is much more complicated because you really have to pay attention to it, and I'll show you an example of this. Okay, so that's a bit some factors. I would also add, I would use durable functions more in the scope of single application. My Logic Apps is really more in integration scenarios. That's how I see that. or let's say a platform component that you want basically to be in the middle of different applications, and logic apps could also, of course, be used. So let's see, durable functions. So that's inspired from a real world project that I don't know if the guy is in the call, but I worked, brainstormed a lot with Erwin de Sterk. So if Erwin, you're there, so I say you hello. And basically, we actually had some specific needs. And we combined the usage of durable functions together with ACIs. So again, I told you ACIs, really the benefit is that you can allocate a lot of compute to a single step. So if you're in a workflow scenario and at some point each step is resource intensive, then each step will run in separate compute environments where you can allocate a lot, right? So, and here, basically the lesson I would say, and that is also, that echoes what I just told you about versioning, is to try not to embed business logic into the orchestration itself, right? Because say that you embed business logic, then you would keep changing versions and so on. So it's going to make your life a bit harder. So you should maybe focus more on the orchestration itself, right? And then here, what we do is basically spin up for each workflow step, spin up a container instance, right? And then, of course, wait for the feedback of that container instance. So here, what I do here, and of course, I just made a very tiny code that I will show you, is I'm provisioning the ACI. I provide already a callback URL to that ACI. So that's kind of a push, let's say, push flavor. So I'm not polling for the ACI to return its status. I find it more scalable to push, right? And then the ACI will actually reach out back using callback URL that I provided, right? To report about its status. If it never reports, you can use timeouts as well, right? Because if the ACI hangs in, let's say, a creating mode for some reason, or if your code never really starts, then it will, of course, not be able to report about the status. So you can have retries and basically, sorry, timeouts. So here, that's the workflow I have created here, right? So that I will demo now. I will show you the code, demo and show you the code. So basically here I have, I would start my orchestration with an HTTP triggered function. It's actually an orchestrator client. So the durable functions come with, maybe I should also tell you just one word. Durable functions is stateful functions, right? For the ones who've never used that. And you know that one of the good features of Azure Functions, well, all the native Azure Functions are stateless. Here it's actually when you need to manage state, let's say for like a workflow, right? So stateless is great, but it's not always applicable, right? So here it's stateful functions, but the statefulness is handled by the durable frameworks. You don't have to do it yourself. So that's the value proposal of durable functions. So here in that scenario, I'm kicking off the orchestration manually. Let's say through HTTP. I'm injecting the workflow configuration. So saying, okay, these are the steps you have to go through. These are the retry. These are the timeout per step, and so on, right? I'm basically defining the workflow logic, but not the business logic, the orchestration logic. I'll show you that. Then I have a main orchestrator for each step. I'm starting a sub-orchestration, right? And in the orchestration, I'm spinning up an ACI. So here it's in red because I don't do it in this demo, right? For sake of time again. I'm waiting, but it doesn't matter. It doesn't change anything to the plumbing. I'm waiting for the, let's say, external event. So the ACI to, let's say, come back with the feedback. And then in any case, right, whether I receive a feedback or whether it timed out, I'm deleting the ACI because, of course, you don't want to have all found ACIs, let's say, in your Azure environment. So you should delete it anyway. And then if I get a feedback, if it's okay, I just go to the next step, so the next workflow step. Else, depending on the retry logic, I retry that step, or I skip it, or I stop the workflow. Okay, that's a bit how it works. So let's see this in action. So we have like 19 minutes, that should do it. So, okay, let me clean this guy. So I will start Visual, let's say start this project, and then we'll look at the code after. So yeah, I hope it will not take too long, because sometimes it takes a bit of time to start the function runtime and so on. So I'm running everything locally here. So that, well, I can close this guy too. So I'm running everything locally, so not in touch with Azure. So if you use, but that's the same as if you use durable functions, then you can use the local storage emulator, right? So that you can test everything from, let's say, your local machine. That's easier. And so here I will basically make a call to this guy, and then I explain you a little bit of plumbing. But first, I want to show you this in action so that then you can see. I will explain the plumbing later on. So I'm going to call this guy. Sorry, I have my cheat sheet to get the demo, let's say payloads, sample payloads. So I'm basically injecting the orchestration configuration, so the logic of the orchestration itself. So here, maybe I will show it from here. So what I'm doing is that basically I have a series of steps, as I told you. So I define a max retry count per step. I can say, okay, if I should stop the workflow in failure, because maybe the step is a required step before you go to the next one. But I'm defining a per step timeout, right? So, and I also have a default timeout for every step, should the timeout not be defined, let's say here. And I'm also specifying if the workflow can be rewind. Okay, so that's also a functionality that you have, at least cannot rewrite to the beginning, but you can rewind to, let's say, the last successful step. So that could be handy at some occasions, right? So that's the basically config I'm injecting. So I'll just change and say that I don't want to, I'll just say 1 retry count, and that's it. Okay, so let me see here. So I'll just kick this guy off. So that should create some activity here. So I'll tell you about the breaking change later. So here you see that got code by the, let's say, function runtime here. So, and it says, okay, it has created the ACI. As I told you, I'm not really creating that, but so that you see the logic. And then basically it's waiting for feedback, you see, of step 1. So here I'm going to use this callback URL, which would be transmitted to the ACI, right? And then I'll basically just use this guy, and I'll say that the status is not okay. Okay, so here, okay, it's accepted. So it tells me, okay, the step failed, right? So, and then because I put a retry logic on step 1, so I said retry once, remember, then it's still retrying that step, so kicking off another ACI, and then I have another callback URL, right? So I'll say, no, this time that this is, for instance, status is still not okay. Right, so I could have it's another URL anyway. So not so okay. Then it should tell me again this is this failed, right? So, and then it will say, okay, step 1 failed, orchestration is over. Why? So I had 2 steps, but of course I said that stop workflow and failure is true, right? So if I now say that I'm starting a new orchestration, so I basically come here, take this guy back, and I'm starting a new orchestration. I say, okay, do not retry, or actually I don't care because I will read the successful feedback. I will say, okay, run this one. So it will start a new orchestration. And then, of course, I can return a callback. This time I will say it's okay. So I, of course, mimicking what the ACI would do. I suppose you understood it. So, and then I'm going to say, okay. And then here it should go to step 2 now. You see, so it's waiting already for step 2. And then if it's going to be the happy hand this time, I'm going to say step 2 is okay. Of course, I could say it's not, but believe me, it works. I think I might have, let's see. Yes, so let's see. Okay, so that's actually, I did paste the wrong one. Okay, doesn't matter. So, well, okay, I just pasted back the step 1. And so step 1 was, of course, already over. So I had the impression that I made a wrong copy paste, but that's it. Anyway, that's working. So no issue there. I just pasted the wrong callback URL. So okay, but let's say here we have then the orchestration logic. That's like this, right? So what I want to show you now is maybe well, maybe a bit of code. And maybe I can already start a new orchestration as well with just one timeout so that you see that this is working. I will say, okay, no retry and stop. I'll just put 1 minute. So, but of course we're not, okay, sorry, that's this URL in the orchestration. And I say timeout, let's say 1 minute and no retry. Okay, so let's see. Okay, so it's going on. So I'll see now, let's see the code so that you can see a little bit of code. So what Azure Durable Framework does is basically storing its state into table storage. Okay, so if you have a look at this, you will find some stuff. That's my local, let's say, of course, emulator. And then you'll see that it stores a bunch of stuff into it, right? So that's really the statefulness. So that's also handy if at some point you have some weird errors or whatever, you can always have a look at this, try to troubleshoot. Of course, you should never change anything manually. And basically here, if I look at the code itself, right, I made it a single, let's say, class so that it's actually easier to read here. But basically, we have, of course, the orchestration, the one that's starting the orchestrator, right? So that is an HTTP trigger function. Of course, in reality, you would put probably that even behind an API gateway or something. But okay, it doesn't matter for this one. So it's starting the, let's say, the main orchestrator, as I told you. So here I have like my for each loop, if you remember the diagram. And basically what I do here is that, of course, I'm taking the orchestration configuration that was injected. And for each step, I'm seeing the retry logic and the, let's say, retry count and the timeout. And basically that's baked into the framework where we can say, okay, you basically call a sub-orchestrator and then you basically pass your retry options, right? Which then encompass the number of retries and the basically how much time between each retry. So I didn't put that as part of the config, but it could of course be the case. And then I'm basically starting this orchestration sub-orchestrator. And so here, of course, I simulate the file I'm creating in ACI, but of course it would be like an activity function that will spin up the ACI and say, okay, if it's okay or not. And then I'm waiting, let's say that's the important bit somewhere. Well, I'm waiting for the external event, right? So that's the guy that will really wait for the external event. So, but something that's very important to understand with durable functions is that it's actually not waiting. So your orchestration is like suspended and it's resumed when there is something happening. So it's not like your function is always running. So you will not pay, you will not waste compute resource and so on. It's actually not waiting. It's waken up by, let's say, storage events, let's say, that is listening to basically process your function. So, but that is very important because it means that your code must be deterministic. So all the things that you see here are replayed, right? And so if at some point you execute, you make a call to an API, and that API is returning different values each time you call, it will crash your orchestration. So you need to work with deterministic stuff. So a concrete example, it's like, okay, if a function returns a grid, of course, it's going to be, let's say, not a static grid, but dynamic grid. It's going to be a different grid each time. So it will, of course, fail. So you have to take into account the replay. Also here, I will not do it, but if I stop and restart, my functions, if it's not my orchestrations, if they are not terminated, I can stop and start Visual Studio, and of course it will resume to where it was, right? If there is an event or something. So it's not like, so it could be perturbating when you're not used to this. So if you are really, you want to start from scratch, you just, clear all the things you have in development, of course, into your local storage and then a local emulator, and then you're good to restart from a fresh start, let's say. So how that works, well, it's really based on this, right? So if I now have a look, you see that in the meantime, when I was basically explaining this to you, it had a timeout, right? You see, so my 1 minute timeout indeed kicked off, and then I said, okay, stop the workflow if the step fails. So that's why the orchestration is over. Something that I didn't show you, but still interesting to see and to know, that you can, of course, from the calling system, the one that starts orchestration, it can get some information about the workflow, right? So you have some you can also terminate an orchestration and so on. So if I take this URL and I go to, let's say, this one, so I'll just clean up this. I will have actually the status of that orchestration. You see, so here it's completed, right? So basically, you can query, of course, both for the stages and see a little bit what is, let's say, happening, right? So now something then to know, as I told you, deterministic code. So say that I'm basically here. Just make something fake here just to show you. If I basically do this, and then it should give me a compiler warning, right? Because I will make use of a method that is not deterministic. So it's really slow today. So you see here, so it's actually complaining. It tells me, warning, the method blah 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 violates the orchestrator deterministic code constraint. So that you could see if you embed, or let's say use a NuGet package, which is basically where is it? The durable functions. Wait, it should be durable functions analysis. Durable. Come on. the analyzer. Well, actually, with that screen resolution, sorry, it's much bigger than usual. It used to appear the first one, and now I don't see installed. Sorry, I don't know. Also, yeah, this is the one. Okay, so this one, the analyzer, right? So this guy will warn you if you make use in your orchestration functions, if you make use of non-deterministic code. So it's important to try to think of embedding this one from the start, so that it will, let's say, save you from let's say, headaches, right? And then you can also mark, because sometimes you might have a warning, but it could be like a false positive. So if you're really sure about your code, you might mark a function as deterministic, and then the warning will disappear, okay? So, but that's something. So if I build it again, it should, oops, I think I cleaned. Yeah, cancel. It should not complain anymore, right? So I'm just rebuilding. So, oh yeah, well, okay, it's still complaining. Well, let's maybe retry. Did you? Well, okay, probably demo effect. That should actually not complain anymore. But anyway, so if you mark a function as as deterministic, that should actually not be an issue anymore. So here you see that why also is it non-deterministic is, of course, because I'm returning datetime.now.toString. Okay, so that's the problem. So if I come back to the code here, so what I want to show you, and then I'll finish with this, is a breaking change. So let me change this one. Where is it again? So I'll first start the orchestration, right? And then I'll change something. So I will restart a new one once it's ready. So, and that is something you would not have with logic apps. So that's an important difference. But it's, of course, manageable with durable functions. You just need to know about it. So if I now start a new one, so it should, yeah, no, I should have started not with time.1, or I'll have to be very fast. Let's try. So I'll basically copy the callback URL. So because now I have 1 minute to change the code and so on. So I will just stop this guy. And I would quickly, so I have the callback URL that was of my ongoing orchestration. So I will basically change. I will say I'm returning int instead of bool. And I will go here, go to implementation. I'll say quickly int, and then I'll say return like come on, 200. So, and then let's restart before the minute ends. So let's see. Come on. Of course, if it takes a minute to start, I will have an issue. So hopefully, come on, start. And then if I know, send my feedback, and I say, even if I say okay, right? So is it ready? Come on. If I say okay, that should anyway return an error at some point. You see, and why? It's because actually I changed the function signature. So you see, it was expecting to have a bool, and I'm now returning 200. So that's an issue, of course, because your orchestration, my orchestration was still ongoing. So as I told you, of course, if you stop Visual Studio or in real life, right? It's even if it's hosted by Microsoft, of course, I mean, it will not change anything. If you have ongoing orchestrations and you make a breaking change like this, changing the signature, returning non-deterministic or using non-deterministic code, you will have issues, right? That's for sure. So, and how that works is because it's using a hub, right? So not this one. It's using a hub. So you see here in the name, it's Azure Task Hub v1, right? And the hub can be specified in the, let's say, in the host one. So where you basically do this. So how do you deal with different versions? You can change the hub. You can also even attach different storage accounts, but there are consequences to each change, so you need to pay attention. But basically, let's say a rule of thumb is to pay attention to the versioning if you use durable functions, right? That's really something important. So quickly go through a takeaway, and then it's going to be over. So logic apps and durable functions are workflow-like engines. So as I said, logic apps are more suited for platform integration scenarios, while durable functions may be more interesting when scoped to a single business workflow. So again, pay attention of using deterministic code and breaking change when dealing with durable functions. Don't forget that there is also durable entities, which I didn't show, but that's interesting. So KIDA brings intelligence of Azure functions tier into Kubernetes, right? So it acts as metric server between your event stores and your and messaging stores, of course, not all the events, and your Kubernetes pods, which are the handlers. Dapper perform some orchestration, right? But state store, service discovery, etc., between services, and can leverage the logic apps runtime to tackle workflow-like scenarios. So Dapper, it was really a small glimpse that you had today, but it's really, really nice. So I really encourage you to dig deeper into that one. And of course, there is a very good, I forgot to show you the pointer, but also at some point, if you're a little bit confused on when to use Event Grid, Event Hub, Service Bus, there is a very good guidance paper from Microsoft that explains that a little bit. So that, and again, they made the difference between discrete events, telemetry, and so on. So it helps, let's say, finding your way in which service to use for which use case. So, and with that, it was quite fast. So you can probably replay some bits in slow motion, that concludes, let's say, the session of today. So Chris or Martin, you take over, I guess.
Yeah, there we are. Thanks for a really cool session. I think you covered a lot of ground in a little bit more than 1 hour. So thanks for that. Chris is joining as well, I see. There are some questions. If you have your own questions that you still want to ask, post them in the chat on YouTube or Facebook or Twitter, and we will pass them on to Stephane. There are 2 questions that already were posted in the chat there. And one is, I don't know, maybe a philosophical question. Is orchestration just another name for advanced job management?
Oh yeah, that's indeed. Maybe philosophical questions. Well, I would say, well, for me, orchestration, you see, the definition is very, very broad. I think, yeah, orchestration, Kubernetes is a container orchestrator, you see, and it's not about job management, but it's still an orchestrator. So it all depends on how you look at it. But of course, if you would match or map that each step is actually a job, right? Then the orchestration, I would define that you will have multiple jobs as part of the same orchestration. And then you have an orchestration as soon as you have to start making the liaison between those jobs. That's how I would define it.
If all right, makes sense. Then there was another question on Dapper. And the question was, if Dapper is still in alpha, will there be a lot of breaking changes by the time it will be in production? Or do you think that the current functionality seems stable enough and they just need to add some functionality and you can already...
They still change a lot, right? So breaking changes, it's hard to predict, right? But there are also, of course, still a few bugs, of course, at this stage. So I reported myself a few bugs. So breaking change, I don't think there will be too many. Although, well, you know, if it's December, we still have 3 months to go. So, well, definitely it's not production ready right now, so that's for sure. The amount of breaking changes is hard to say. No, they are also trying to improve, and they receive a lot of feedback, also positive feedback to improve it, right? And maybe sometimes to improve a new feature, really, that could be make it Dapper richer, it could go to breaking change. So I think that if, at least that's how I would run it myself, I mean, it's the time to make breaking changes when you're in alpha, right? Because once you have a production version, then it starts to be harder. So yes, we might think that there will be at least a few ones, but yeah, maybe better to really ask it to the Dapper team or GitHub or something to make sure.
All right. It looks like that is it for questions. Now, given there's a small delay on us asking the question and people posting something, I'll give you a couple more seconds to post them. If not, I guess we can wrap up. It's definitely been a very nice session, and yeah, I guess you're tired of speaking as well.
Yeah, no, but it's okay. Yeah. So
we're getting good feedback on your session already, by the way.
Great.
So people seem to be loving it, but they're going to review it again because it was like extremely fast-paced.
Yeah, it's a bit. I know it was a bit fast, but that's the positive thing about recording is that you can always pause at some point.
Of course.
So yeah.
People play videos on YouTube at 1.2 speed, but this is going to be one for 0.8 or something.
Yeah, indeed.
No. The thing is that I even had much more, but then I already cut. But of course, then I hesitated to cut, for instance, Kida, but I also love Kida, so you know it was a bit. Yeah, so I said, okay, let's try in 75 minutes. It's gonna be a bit fast, but again, it's recorded, so can always watch back.
All right, we do have one more question.
Yeah.
is with orchestrations that have breaking changes, can I return a class and expand or create a subtype for the return value and use that expanded data? Will it all keep working, or will you see crashes? What's going to happen?
Well, actually, I would say that you just have to think that the thing will be replayed, right? So if when you replay, it gets different value, then it will crash. That's a rule of thumb. So no matter what type you return, it's actually even looking at the value, because the type, I didn't show it, but in the example I showed was like int to string. Say that, it was bool to int, right? And the first iteration, or let's say when the orchestration was started, I returned a false. I didn't show you because I had to rush. But if when I changed to int, I would have returned 0, it wouldn't have crashed. It's really looking at the value, you see? So so that's a bit that's also why it's really tricky, because that example, which I'm changing the function signature, I'm returning a let's say a 0 int instead of false, and that would not crash. You see, so it really depends on the value, and of course the type plays a role. If you really have strong types like custom types, then of course that the type, I think, will indeed play a role. It's not only the value. So for scalar types, it looks at value, and for strongly types, let's say classes and so on, objects, it will of course crash if you start mixing.
Do you have any best practices or ideas on how to overcome those crashes or avoid them?
Well, best practice is really to think of versioning. So make sure that you do not just replace the function app, right, that you have today. So when you have a code change, that you just not push your, let's say, when I say replace the function code on the same function app. So there are some versioning strategies. So either changing the hub, because then if you change the hub, there cannot be any collision between the running orchestrations and the new ones, because they will be stored in a different container, in the different table storage, in different table of your table storage, of your storage account, sorry. Else you can also even change the storage accounts, right? So that there are some strategies. There are also some downsides. So I mean, depending on the strategy you use, but what is sure is that you should not just redeploy blindly your code on the existing storage account, function app, and underlying storage account, because that's, unless you have no breaking change, of course. So best practice would be change the version, at least the task app, right? Because then you take no risk, because if you didn't realize that you have a breaking change in your code, then you will have issues, right? And if you already have production ongoing orchestration ongoing in production, then you will of course run into troubles for sure. Right, so best practice: change the task hub or change the storage account, but do not redeploy to the as-is function and storage account. Right, that's what I would. Good.
All right, no other questions are coming in, so I guess we can wrap up. Again, Stephane, thank you for presenting. Everyone who has joined us today online, thank you for joining us.